Hello, in this video I'm going to do the second half of the free response from the 2023 exam. So we're resuming with problem number 4. So problem number 4, they're giving us a graph, and this is a very common thing. This is the graph of f prime. They're telling us it's f prime. Sometimes they give a slightly different relationship, but they might not literally call it f prime, but you have enough information to figure that out. So they cover their bases here. It's defined on the closed interval from -2 to 5, satisfies f of 2 equals 1. I'll almost certainly need that later. And the derivative is graphed here. So that means it's differentiable and therefore continuous. Okay, so does f have a relative maximum, a relative minimum, or neither at f equals 0? So we need to think about, well, what happens at a relative maximum, relative minimum, at what does the derivative f prime do if f has a local maximum? Right, so at a local maximum, right, this is just my scratch work. At a local maximum, the derivative switches from positive to negative. At a local minimum, the derivative switches from negative to positive. What we are noticing is that x equals 6, f prime does not change sign. So it is neither a minimum nor maximum. You need to give a reason there, right? This was just one point. Answer with a reason, period. Okay, on what open intervals, if any, is the graph of f concave down? So this is where we want to do a little bit of a relationship. F concave down is the same as saying f double prime is negative, is the same as saying f prime is decreasing. If you're not clear on this, you can do it on the side, but don't really make it part of your presented solution. So we can say f is concave down where f prime is decreasing. I'm actually giving the reason before my answer. And now let me just go looking for it. Where is f prime decreasing? On the interval from -2 to 0, and on the interval from 4 to 6. We just give the x coordinates. So on the interval from -2 to 0, and on the interval from 4 to 6. Let's just double check that. That looks good. Okay, now find this value. It's a limit, so our first instinct is to plug in. So f of 2, we plug in 2. Let's just remember, we were told, let's scroll up. We were told that f of 2 is equal to 1. This is kind of our reminder that we know that. So I know f of 2 is equal to 1. So if I plug in x equals 2, I would have 6 times 1, which is 6, minus 6. The top is 0. If I plug in 2 here, I would have 4 minus 10 plus 6, which is 0. This is a 0 over 0 limit. We'll use L'Hopital's rule. And the AP is very picky about this. If you're going to use L'Hopital's rule, you want to unambiguously present why you're allowed to. So we will write formally the limit of the top function equals 0, and the limit of the bottom function also equals 0. So we may apply L'Hopital's rule. So the limit as x approaches 2 of this thing, you could probably get away with not rewriting it. We can take derivatives. It's the limit as x approaches 2 of 6 times f prime of x minus 3 over 2x minus 5, and let's try plugging in again. So this is 6 times f prime of 2. So we will notice the grid is here to make it really nice. Oh, actually, f prime. This is the graph of f prime. F prime of 2 is 0. have that directly from the graph. So f prime of 2 is 0. That's 6 times 0 minus 3. And then down here we would have 4 minus 5. So that is negative 3. You don't have to simplify, but this looks like it's working out to 3. And let me just scan. Yeah, so I think you can get 2 out of 3 points if you use L'Hopital's rule but do not present it correctly, which seems reasonable. Now find the absolute minimum value of f. So here's what we know. We know, and this is a good sentence to lead with, f will have a minimum at an endpoint or a critical point. And what I will also mention is the only critical points, endpoints might technically also be critical points, but something that you can mention here is that we can only have we can only have an absolute maximum at a critical point if that critical point is a local minimum. If I have a critical point that's a local maximum, this is clearly not the absolute minimum. If I have a critical point like this that's neither a minimum nor maximum, that's not going to happen. So we can be more specific here. All right, and you could have just led with this second sentence. More specifically, f will take a minimum at an endpoint or a local minimum. And let's look at the graph again. A local minimum occurs when f prime switches from negative to positive. And we can see the only time f prime as we go across the graph switches from negative to positive is at x equals 2. So we can say a local minimum occurs when f prime switches from negative to positive, and that occurs at x equals 2. Our endpoints are x equals negative 2 and x equals 8. So we have narrowed it down to 3 possibilities, and now we can just check them. So I'm going to make a little table here. Here is x, and we want to evaluate f of x. So negative 2, 2, and 8. Now, it might not be obvious how to evaluate f of x. We have a graph of f prime. We need to think about integrals. I have, and pay attention, this issue comes up a lot. This is a very common problem type. They're giving you a graph of f prime and one piece of information about f, that f of 2 is equal to 1. Let's double check that we read that correctly. And we want to find other values of f. No one is asking you for a formula for f, so don't try to find it. You are being asked for specific values of f. So what we can do is we can use the fundamental theorem of calculus, aka the net change theorem. The change in f is the same as a definite integral of f prime. If I want to know how much f changed, I can take a definite integral. And we know the value at 2, so we can just measure backwards and forwards from 2. Let's make this concrete. So f of 2 is equal to 1. We'll just plug that in. To find this, so I will label this as the work I'm doing. What I know is that the definite integral from negative 2 to 2 of f prime of x is equal to f of 2 minus f of negative 2. That's just fundamental theorem of calculus. Here I am integrating the derivative. Here we are measuring the change in the function of f. And I know that this is equal to 1. I can also find this definite integral from the graph. They intentionally gave us a graph with lines and semicircles so that we could compute these fairly easily. So the definite integral from -2 to 2 would involve this positive area and this negative area. This is a triangle that's 1 by 2, so the area of that pink area is 1. And this one down here is 3 across and 2 down. 1 times 3 times 2, which is 3, and that counts negative. So this is 1, this is -3. That definite integral is -2. You do not need to show where that comes from if you are giving the correct notation and giving the correct answer. That speaks for itself. So we subtract that. And f of -2 is equal to 3. To find f of 8, we can do the same thing. The definite integral from 2 to 8 is f of 8 minus f of 2. F of 2 is 1. So f of 8 is equal to 1 plus this definite integral. So let's find that. What you might notice, right, and if you are worded this well, you would not have to go through all the details. But whatever integral we get here is going to be positive. So you could probably get away with just saying that whatever integral we get is bigger than 2. But we can do this. So this area here, it's a 2 by 2 triangle, so the area is 2, 1/2 base times height. And then we want to find this stuff in orange. Oops. And the orange stuff is a rectangle minus a semicircle. That rectangle is 4 by 2, 4 units wide, 2 units tall, minus half of a circle, and that circle has a radius of 2. So the orange stuff has an area, not 4 squared, 2 squared, which is 4. So that's basically 2 pi, right? The area of the semicircle is 2 pi, the area of the rectangle is 8. So the combined area here is 2 plus 8 minus 2 pi, which is 10 minus 2 pi. I know I'm doing this maybe not in the best way. 10 minus 2 pi. So this is 11 minus 2 pi, which even with a rough estimate is bigger than 1. Because remember, we're trying to find the minimum. So we have checked all of the relevant places. We checked the endpoint on the left, we checked the only local minimum, and we checked the endpoint on the right. Let's remind ourselves of the instruction. Find the absolute minimum value of f. The value just means the y value. So the minimum value of f is 1. That's our final answer. Let me just check the official solutions as we're going. Okay, let's look at number 5. Big table of values. Let's not worry about that too much. Obviously, the information we need will be there. So we have 2 functions. They're twice differentiable. Okay, so that's interesting. Even though we don't have their second derivatives, we're told that we can calculate a second derivative. All right, A. Let h be this function, find h prime of 7. Okay, so first we will find h prime of x, and that requires chain rule. So h prime of x is f prime of g of x times g prime of x, just outer times inner. Write the formula, write clearly what you are doing. If you do stuff in your head, you will lose points. And you will get the wrong answer. You want to demonstrate how well you know calculus. Just writing an answer is not a demonstration of knowledge. It is a limited demonstration of knowledge. Okay, g of 7, if we read this diagram, is 0. G prime of 7 is 8. F prime of 0 is 3/2. So we have 3/2 times 8. You're not required to simplify, but that works out to 12. All right, part B. Okay. So now they give us this thing that is k prime, and they're asking us about concave up or concave down. So we need to figure out the second derivative. So let's take a derivative. K prime of x. Now this is going to be product rule, right? It's two things multiplied together. So it's going to be the derivative of the first, which itself is a chain rule problem. I'm going to leave that blank. Times the second, plus the first, f of x squared, times the derivative of the second. And in here, I am going to do chain rule. Right? So this is a product rule problem with a chain rule step. Just go slowly, show your steps. Outer function is squaring, so outer derivative is 2 times f of x. Inner derivative is f prime of x. And now we plug in 4. So k double prime of 4 is 2 times f of 4 times f prime of 4 times g of 4 plus f of 4 squared times g prime of 4. All right, what do we got here? F of 4 is 4. F prime of 4 is 3. G of 4 is negative 3. G prime of 4 is 2. We do need to simplify this because we have to figure out if this is positive or negative. So here, this is 2 times 4, which is 8 times 9, 72. This is negative 72. And 4 squared times 2 is 32. This all works out to negative 40. So why did we do that? Because we want to know if we're concave up or concave down at that point. So we notice that this is negative. K double prime of 4 is negative. So K is concave down. Make sure it's clear what your answer is at x equals 4. This was 3 points. Basically 1 point for demonstrating that you know some of the derivatives, 1 point for getting the correct answer, and 1 point for the right conclusion. All right. A lot of abstract stuff here, just practicing various rules. Okay, so now we want to find m of 2 for this function. So let's just plug in and see what we have. M of 2 would be 5 times 2 cubed, which is 8. Plus the definite integral from 0 to 2 of f prime of t dt. So we need to make sense of this integral, and we need to realize, oh, it's a definite integral of the derivative. They're just hoping you notice that. So this is 40. And then by the fundamental theorem of calculus, this would be f of t from 0 to 2. So this is 40 plus f of 2 minus f of 0. F of 2 is 7, f of 0 is 10, so this works out to 37. That was just 1 point. Either you figure it out and you show your work or you don't. And now, is the function we found before increasing, decreasing, or neither? at x equals 2. So we need to analyze its derivative. Okay, so here is m. I'm just going to paste what m was. So let's take the derivative. Let's write m prime of x, and then we'll plug in. So derivative of the first part is 15x squared. Now here we need to recognize this. This is a function defined using a definite integral. By the second part of the fundamental theorem of calculus, this is just the inner function with x plugged in. And the inner function is f prime. So you want to realize we are not actually doing any calculus to that. We are just taking x and plugging it in for t. That's how the second part works. So now m prime of 2 would be 15 times 4 plus f prime of 2. So that's 60 plus f prime of 2 is negative 8. Which is 52. So we can say m prime of 2 is positive, so m is increasing at x equals 2. Put your finger on exactly what you noticed, right? Say m prime of 2 is positive. Don't just think it. All right, last one. So consider the curve with this equation. The whole point here is we don't know what that looks like. Right? It's too complicated to even guess. But if we understand the relationships, hopefully we can figure